Okay, so what is a load balancer and what is the load balancing? First, we need to understand what exactly the load balancing and how it works and what is the benefit of using it. Then only we can able to set up the load balancing. If you understand clearly how the load balancer works, then we can able to set up it correctly. Okay, so before understanding the load balancer, if you see the terms, right, load balancer, okay, AWS provides like ELB, the service elastic load balancer. Okay, elastic load balancer, and it's the service has the load balancing type has four types of load balancers available. Okay, we'll discuss everything. Let's see what exactly the load balancer is and why you want to go for it. So in computing, load balancing refers to the process of distributing a set of tasks over a set of resources with the aim of making their overall processing more efficient. Normally in computing, what happens? Load balancing refers to the process of distributing a set of tasks over a set of resources. So resources could be your the servers, right? Your servers where you can distributing the task among multiple servers so that everyone could be equally loaded and equally serve the request received from the customer or the client. So a load balancer normally acts as the traffic curve sitting in front of your servers and routing the client request across all the server capable of fulfilling those requests in a manner that maximizes speed and capacity utilization and ensures that no one server is overworked, which could degrade our performance. That means if you have seen the real time the traffic signal, right? So based on the traffics, it will be time bound, like based on the time set of the timer set of the traffic leaves it, like the traffic goes it gives the signal and the people goes away, right? And based on the side which is overloaded, right? If there is some emergency which is overloaded, and they will leave that path that way clear and that will go away. Similarly, in load balancer also, if we put as it is a traffic curve, it decides whatever the request gets from the customer, like from the end user, where it should be trafficked, where it should be go. Okay, so it will decide, and based on the server's capacity, based on the resource availability, it will decide and route the client request to the servers. So what will happen? It will equally distribute the task. That means no server will be overloaded. So the load balancing, the balance of the work will be equal. So what happens if a single server goes down, the load balancer redirects the traffic to the remaining online servers. When a new server is added to the group, the load balancer automatically starts and sends the request to it. Like suppose we have four servers available. If we have four servers available, so what will happen? If in case any one single server is goes down, will have still three servers available to serve the request, serve the client request, right? So what will happen? That server, whatever request comes to that server which is immediately went down, that request will be redirected to the other available server. Also, if there is demand increases, if there is some demand increases, we got more customer, we got more client, more project, more resources required, so that we can add new servers also, new servers to the template or to the target group. So what will happen? Automatically load balancer will start sending the request as soon as we registered the new server, the IP address to the load balancing template or load balancing target group. Okay, we will see that in action when we create our load balancing group and set up the load balancer. So before that, let me explain you more on the how the load balancing works. So if you see this diagram, right, we have the end users here and the internet connections over there, and we have the load balancer sitting in between the end user and the servers. Suppose we have 4 servers online. We have made the target group, and the template is having 4 servers, and our load balancer is actually registered for these 4 servers. Currently, suppose whatever the request comes, most request comes, it is sending the request to the third server. Okay, suppose what happened, in case anything happened, one of the server is goes down, so what will happen, the immediate request will go to the another available server. So the traffic, the request comes from the end user will equally distributed to the available server. Okay, so what the functions, actually the load balancer performs these are the functions being performed by the load balancers. So what it does, it distributes the client requests or network load efficiently across multiple server. It distributes client requests or network load efficiently across multiple servers. So it ensures high availability and reliability by sending requests only to servers that are online. Make sure, that is very important point to remember, only the servers are online, the load balancing will work. It will send the request to the availability only to the online servers, or which are the running servers. Okay, it provides flexibility to add or subtract servers as demand dictates. So it works based on your demand. If the demand increases, right, it has the flexibility to add more resources. Also, if your demand decreases, you can also still subtract or decrease the servers or resources from your load balancing target. Okay, it has the flexibility to do that. So what are other benefits of using it? It reduces the downtime, so we'll not get any downtime if you're going to use the load balancer, because we'll have multiple other same servers, multiple same servers which is hosting the same applications available, so that in case of any server goes down, we'll have still other servers available to serve the request, to handle the request. It provides the scalable benefits of using that, redundancy, flexibility, and more efficient. Okay, now let's see type of load balancer. What are the types of load balancer available? So we have 4 types of load balancers available, but the classic load balancer is actually the previous generation, well, the old generation classic load balancer, which is being taken over by the application load balancer. Okay, so those were the classic servers being used. They can use this, they're using this classic load balancer, but it's no more being used now. It can be deprecated, but it is still there, because most of the guys, they are using the EC2 classic instances, right, that still being used by the classic load balancer. But this application load balancer, we have network load balancer and gateway load balancer. So we'll see in details what exactly the application load balancer and how it works, and which networking layer it works. Okay, both application, network, and gateway load balancer. So let's see about what is the application load balancer. So yep, the application load balancer are best suited for load balancing of HTTP and HTTP traffics. So it works on the web applications, right? For web application, web servers, and it operates at layer 7. That is our application layer, layer 7. If you, most of you, I think from engineering and BTech background, I think, so you would at least have some ideas on the networking, right? What is this networking layer? We have that OSI model, right? 7 OSI model. So that's falls on the, so before explaining more on this, let me just explain about this OSI model. So we have this OSI model, the physical layer, 7 models are there, 7 layers, right? 7 layers are there: physical layer, data link layer, network layer, transport layer, session layer, presentation, and application. 1 2 3 4 7. Okay, up to 7 layers. So the our application load balancer falls under application layer, that is layer 7. It uses HTTP, HTTPS protocols, FTP protocols and all. And network layer falls on the transport layer. Network load balancer falls under this layer 4, which is transport layer, which uses TCP and UDP. Okay, so if you see here, application load balancers are best suited for load balancing of HTTP and HTTPS traffics. They operate at layer 7. They are intelligent and we can create advanced request routing, sending specified requests to specific web servers. Okay, whenever we handles the web applications or applications which is being used these protocols HTTP and HTTPS traffic, then we'll go with the application load balancers. So when and why to use this network load balancer? Definitely in interviews you'll get questions, what is the difference between application load balancer and network load balancer, and when to use network load balancer, when to use application load balancer. Okay, so the network load balancers are best suited for load balancing of TCP traffic, transport control protocol traffic, where extreme performance is required. It operates at layer 4, that is the transport layer. Okay, so network load balancer are capable of handling millions of requests per second while maintaining the ultra low latency. So how the network performance, how you get it, that is what is low latency, that means high performance. Low latency, high performance. High latency, low performance. Okay, so latency in the network, the latency refers to the performance of your network. Okay, and it is used for extreme performance. So when you need your applications, okay, your applications for your some applications, okay, think about Amazon, right? If you think about Amazon e-commerce site, they need high performance otherwise. And most of the trading applications, if you go to most of the trading applications, they will be definitely set off the network load balancers in their applications to make the high and extreme performance of your applications and the network traffic request. So that's why it handles millions of requests per second. Okay, so you'll go for network load balancers. Now, so what are other load balancers? We have gateway load balancer and classic load balancer. As classic load balancer is no more being used, as it is the legacy classic load balancer. You can load the balance using HTTP the layer 7. Okay, so we are not going to use this one, and the gateway load balancer I will explain you while we create the load balancing and set up the load balance. That time I will explain you when to use the gateway load balance. Okay, now we have another thing, is this is what about the load balancing. Okay, now we have another load balancing, is the cross zone load balancing. So we can keep our load balancing in two different availability zones, and then we can set up a cross zone load balancing to balance our load or send the request to different availability zone. Okay, let's see how it is done. What is the cross zone load balancing? First, cross zone load balancing enables you to load balance across multiple availability zone. Load balance across multiple availability zone. So if you see here, think about if we have not set up the no cross zone load balancing, and for that we need actually route 53. So when we go with the route 53 services, we'll understand more details about this load balancing, how we set up. So between end user, we have the internet. This route 53 is being set up, being used to route the internet traffic. Okay, internet traffic. So if you see the internet traffic goes, we have zone 1A, 1B, two zones are there. In both the zones we have application load balancer set up. If you see the diagram, in both zones we have load balancers set up. Okay, and in this zone 1A we have 4 servers, 4 instances, and one B we have only one instance. But we have set up our route 53 in our internet network in that all the request whatever receives, it will be equally distributed to the availability zone, both availability zone. Suppose 50% goes to 1A, 50% goes to 1B. But the 50% goes to 1B, 1A will be equally distributed to among all 4 servers, which will be 12.5, approximately 12.5, and everything will be like equally loaded. So less loaded because all the work, 50% work is equally distributed among 4 servers. If you think about 1B, what happens here? This server will be exhausted, right? Because it takes all 50% of request and handles it. Single server handles 50%, and this 4 server handles 50% alone. So whatever, it will be exhausted. So to overcome this problem, what will happen? This server will be slowed down, right? The request whichever comes to this zone will be getting slowness. The people will get less response, slow response, right? So to overcome this problem, we can set up this cross zone load balancing, where we can distribute the request, the load from zone 1B to zone 1A. Whatever the 50% request comes to zone 1B, it can be distributed among with zone 1A. So what will happen? Equally among 5 servers, the task will be distributed now. So this is what about all this load balancing, how, and it will say how it works. Okay, now this is time to do a practice. Okay, do you have any thing to discuss, guys? Any doubt or any thing we'll discuss, or we can just do a lab class, then that time you can understand more detail how it works. Or if you can add anything else or more. Okay, so this was what about the
Is there only one type of route that we are using?
sorry, one type of
Is there only one type of route that we are using, like you said, Route 53, right? Are there any other type of routes as well that we use for load across cross zone load balancing?
we can see this is what Route 53 is being provided by the AWS, right? This is the routing
Yeah.
DNS creation management service. So you can use different in your company if you are using different services. Yes, you can use it. If you are not, if you are using other cloud provider, yes, you can use. But the technique and setup will be mostly same. Okay.
Okay.
So, so let's go ahead and do a load balancing setup. Okay. So let me just okay. So before going to the load balancing setup, let me tell you, we need a minimum of we need minimum of 2 servers to set up the load balancer. Minimum of 2 servers. We to achieve the load balancing, we need minimum of 2 servers, 2 online servers or available servers. For that, let me create 2 servers quickly here. Okay, I have the templates available here. Let me see if any instances they are running. Let me take it. Okay, fine. So we can use the template from our previous classes to create the instances. So let me quickly create by using the launch instance template. See how it will be beneficial now. Okay, so I'll use the template called ABC Banking, which we had discussed in our last class. Okay, and select the version. This is the version 1, and I can create 2 instances now. Number of instances I need, suppose 2. Okay, then what we can do, we can simply go ahead and create, select and do the launch instance. But I'll not do it. What it will do, it will create 2 instances with the same setups. Now I need to change something to demonstrate how the application load balancing works. Okay, now let me just give one and I need to change the user data section. I'll add in advanced details, I'll change the user data. Okay, here I need to change the user data. So let's remove this and just add. Okay, so what I can do here, a little bit adding spaces over here, so just giving this as server 1. Okay, and let me give this as h1 tag. Let me copy for another one. Let's see. Okay, launch instance. So let's go ahead and create another one. Okay, I gave that one is instance 1. Okay, I just gave this application name as the server 1, and here the application name I'll change to server 2. Okay, I'll paste this one and I'll just make it to server 2 launch instance. So let's see, we'll have two servers now running, right? One is running, another is in pending state. Let both the servers run. Okay, by the time both the servers run, let me go ahead and create. See, as I said, we need minimum of two servers. We can add as many as servers you need for your requirement. Based on your capability and resource availability, you can add it. Okay, so what we have to do first, we have to create a load balancer template, or we can create a target group, load balancing target group. So let's go ahead and create a target group here. So in this target group, we have to specify what are the details and servers we need to add into the load balancing and how we can access it. Okay, let's go ahead and create a target group here. Good. So here we have different types of options available here. We have instances, IP address, lambda function, application load balancer. All these options you have to choose and select based on your requirement. Okay, so when you to choose instance, it supports load balancing to instance within specific VPC, and it facilitates using of auto scaling. It facilitates a using of auto scaling in the load balancer. We can use auto scaling to manage and scale our EC2 capacity. Suppose yesterday, right, we are discussing about how we increase without changing the IP addresses and the server details, right? So we can use and combine the auto scaling group in our load balancing. So that what happen in the auto scaling template, whatever you have set up, how many resources you need, how many servers should be automatically created, or what are the resources will be being created, we can all set off using this auto scaling group. Once the auto scaling we set up in the load balancer, everything will be taken care. Suppose we need our customer goes off, right? We need a customer increases, and or we got few more projects, we need more resources. So what we can do, we could set off our auto scaling group, and it automatically scale off few more resources, so that it will once you automatically scale up few resources, what will happen, as it is being tagged or added into load balancing will automatically register those servers. Okay, and will not worry about any IP address or any private IP or public IP or anything, because once the server name is registered on the target group, it will work. The load balancer will take care everything. Okay, I'll show you everything, when to use private IP, when to use DNS name, when to use instances, everything I'll show you in the upcoming uh, pages. Okay, so here when to use IP addresses, if you need to support load balancing to BPC and on premises resources. If your applications are hosted, few applications are hosted in the on premises servers, your application is hosted few of the on premises server, so you have to use the IP addresses of the on premises server, and you have to choose these options to support from BPC and on premises resources, and it facilitates the routing to multiple IP address and network interface on the same instance. So you have to choose for IP addresses. And the lambda function, it facilitates routing to a single lambda functions. So if you are good and familiar with lambda functions, then if you are a company using this one, then you can use this load balancing for lambda functions. Okay, and application load balancer, which offers the flexibility for a network load balancer to accept the route TCP request within specific VPC. But I'll just show you now for instances, then I'll show you with IP addresses. Okay, let's go with instances first. Give a target group name. Suppose I'll give a group name as my ELB instances. Okay, and as we are going to use application load balancer, and it's be used the HTTP protocol, and default port of HTTP is 80, default VPC, and protocol version is HTTP 1. Okay, and this is what you have to give the default one, we have to use based on your requirement. HTTP 2 if you are a company using, or HTTP 1 you have to choose accordingly. Okay, now health check. Health check is very important for the load balancer to set up. Okay, the health check, we have set up here the protocol HTTP, and you have to specify the path where it will be perform the health check. You have to do what is given, use the default path route to do the health check. Okay, so I've given the route to do the health check. So there are advanced health check settings available here. The port, traffic port, the port the load balancer uses. Okay, and healthy threshold, like the number of consecutive health check successes required before considering an unhealthy target as healthy. So if a target is unhealthy, so it will do consecutive 5 times health check. If it finds healthy, then it will display healthy, or it will be unhealthy. And the unhealthy threshold, if it finds, if a server is healthy, it will do the health check, it finds unhealthy in 2 consecutive checks, then it will show the server is unhealthy. And timeout, within 5 seconds, 2 times it will do, and within 2 times the timeout is given 5 seconds. Within 5 seconds, if the server, it will check the server status and give the report. Interval, 30 seconds interval, it will do the check. Success code is 200, and tags, if you want to give any tag, you can provide the tags over here. What is this success codes? The HTTP codes to use when checking for a successfully response from a target. Okay, so we can do all the setups now for a specific group. So this is what, now we set up the health check and the protocol details. But now it comes the server configurations. We have to configure the server in the target group. This is the template we are preparing for the load balancer. Okay, this is the template we are preparing for the load balancer. Okay, now we can see we have our, both the servers are running, right? Both the servers are running. So what we can do, we can select all these servers, 2 servers. So it says available instances. I have 3 instances in my account, but it shows only 2. Why? Because these 2 are only online or available. These 2 instances are running. That's why it shows 2 only. So select these 2, include as pending below, because we need to register these 2 servers. If you want to add, remember, load balancer will not automatically add if you have not set up the auto scaling group, it will not automatically add new servers. You have to manually register the servers. Okay, you have to manually register the servers, and you have to do the auto scaling if you want automatically scale the servers. Okay, now whatever the servers is available here, to just include as pending below, include as pending below here. Now you can see the status here, health status, it is pending. Now let's go ahead and create the target group. So in the target group, we have now two servers added. Okay, we have now two servers added. Now let's go ahead. You can see here, it uses the port 8 protocol and target type instance. No load balancer is associated. It says non-associated. Nothing is associated yet. So if I go and check this load balancer, we'll see the number of targets and how many are healthy and how many are unhealthy. So if we can see here, we have two total targets, 2, unused 2, and we have two servers. Sorry, we none of them are healthy, none of them are unhealthy. So what we can do now, we can simply select this and register the targets. Okay, anyway, our servers are registered, we don't need to do that again. So our servers are registered. So why then these are still unhealthy? Sorry, why are still it is unused? Because see, we have only used. So before that, let me go to the instances and check whether what is the status of the instance. Okay, so why it is still unused? We have not set up the load balancer yet to do the health check. Okay, to do the health check. Okay, so okay, the status is both are running, but still here it is unused. Okay, so let me go ahead and create a load balancer. So we created the target group. Let me go ahead and create a load balancers. So in the load balancer, create a load balancer, and you'll see here we have three load balancer displaying here, but still we have the classic load balancer also. Still we have the classic load balancer, as this is the previous generation. Okay, will be not those who are using the EC2 classics only, they will be using this classic load balancer, and it is the application load balancer is newer generation of this classic load balancer. Okay, we are not going to use it anymore. Now when to use the gateway load balancer, you have to choose a gateway load balancer when you need to deploy and manage a fleet of third-party virtual appliances that supports Genevieve, and these applications enable you to improve security, compliance, and policy controls. For if you need more security, compliance, and policy controls, you have to go choose with gateway load balancer, but most of the companies are mostly using this network and application load balancers. So we have to deal with this too. You have to understand when to use what type of load balancer for which requirement. If you understand clearly, then you can do the setups. Now let's go ahead with application load balancer. Okay. Just give a name to the load balancer. I can see as my ALB. Okay, if you see how the application load balancer works, just click on this. It will give you the details. That is what we discussed, right? What it says, your client makes a request to your application. That means your application is being been clicked by your client or used by your client. Okay, so the listener in your load balancer receive the request matching the protocol and port that we configure. We set up the listener, right? We set up the listener like the protocol and port number 80, and then we set up the target group, right? What then happened? The receiving listener evaluates the incoming request against the rules you specify, and if applicable, routes the request to the appropriate target group. So we can use the HTTP listener to offload the work for the TLS encryptions. If you need the security one, right, secured way, so you can use HTTPS. So healthy targets is one or more target group receive traffic based on the load balancing algorithm and the routing rules you specify in the listener. So this is how it works. So ELB listener, we set up HTTP 8 or HTTP 4s. Based on that, it will just receive it. Okay, that's simple. I'll just explain you. Now, give the load balancer name and here. So yesterday Sanjay was asking about the private IPs. Okay, so the private IPs we cannot set up for internet facing. Okay, for application load balancer for internet facing we cannot set up the private IPs. We can set up for the internal applications which are being internally available for the private VPC like the virtual cloud, okay, virtual private cloud. And when you go for internal, an internal load balancer routes requests from clients to targets using your private IP addresses. Okay, for internally you are accessing your application, then you have to go for internal, and that time you have to choose for your IP addresses. Only you have to select the IP addresses. Okay, we selected now the instances, right? That time you have to select the IP addresses. Now let's go for internet facing. So most of the application load balancer, okay, the clients and the customers whoever is accessing, that will be internet facing. An internet facing load balancer routes requests from clients over the internet to targets, the targets whatever you we created, and it requires the public subnet for the internet facing. We cannot add the private subnet here, only the public subnet will be added here. Now, IP addresses, we can choose either IPv4 or IPv6. So if your application supports both IPv4 and IPv6, if you have set up for your application, your network supports, if your network supports both IPv4 IPv6, then you can select for the dual stack. Okay, let me select for IPv4 now. Network mapping, default server VPC I have selected. Let me map to two different availability zone, 1A and 1B. Okay, now let's go ahead and add a security group. Okay, so I have a security group here, lamp SG, and this security group is having the port 22 and 8080, because 80 is the protocol for is the port for HTTP protocol, and that is required to be whitelisted to be accessed from the internet. Okay, that's why we have to add the security group which is having the port 80 whitelisted. Now here you can see the listener. I was talking about the listener, I was showing about in the diagram, right? The listener. Now we have to set up the listener to listen the request from the internet traffic. So load balancer will listen the request from the user. So we have to set up the listener, and we get the request from the listener, and it will forward the request will forward to the target group. We have to select the target group which we have created. If you have not created the target group, we can still have option to create here itself. Okay, now our listener will get the request and send the traffic to this target group, and this target group is having two servers inside it. Okay, two servers. Now Addon Services, if you need additional like AWS global accelerator for high performance for you can add it, but you have to pay some monies for that. Okay, if you're going to use static IP addresses, create an accelerator to get static IP address. If you're going to use static IP addresses to improve the performance, you can just click on this. You'll use the static, just give a name, accelerator name, and you'll use it. So it adds some additional charges. Give the tags optional, it's up to you. Name whatever you want. Suppose I'll give name as these all are, suppose, dev or prod server. What happened? Let it slow down. Prod server. Okay, that's all. Let's go ahead and create a load balancer. I can give a name as load balancer ALB ABC. What it says? It says I already have a load balancer with the name. Why? Okay, fine. Now let's go ahead and create a load balancer. So view load balancer. I have only one, but I think I'm not sure the page was not refreshed. That's why it's didn't show. So we got our load balancer now created. It is in provisioning state. Still, it is in provisioning state, and it available in both availability zone 1A and 1B. So let's refresh it. It will be in active state. So before that, let me explain all these configuration details. So what we need now, we have this ARN and name of this and status provisioning and all these informations. We need this DNS name to access our application. Now we don't need any server DNS, or we don't need any server IP address to access our application. We can application this DNS now will be internet facing. This will now be internet facing. Okay, anyone from the internet can access this load balancer. Okay, just wait for some time. And okay, now if I go ahead, okay, so it is in provisioning state. If I go ahead to the target group and check whether the servers are healthy or not, okay, if I go ahead and click it here, still we have our checks are unused, right? All servers are unused, it is not used. Now it is just doing another health check. See, it is just doing the health check now within 30 seconds interval, right? It is doing the health check. So doing the health check, let's refresh it. Okay, now we can see here two servers are healthy. Total servers two servers are healthy, none of them are unhealthy. Okay, if I go to the load balancer now, we will see it will be active. See, it is now active. Okay, now if I copy this load balancer or the DNS name, you can also, I just ping you in the chat, you can also try at your end to access this. You can able to access also. Okay, just copy paste and in your browser and check whether you can able to access or not. See, if I paste it here, see, our request goes to server 2. Our request goes to server 2. If I send another request, see, it goes to server 1. So see how the request goes, right? If I replace directly how the server goes, based on this request I sent from the client, it will go to server 1 and server 2. The request goes to here. Okay, now, so we have now two servers added, and we saw here how these servers are being redirected to both of the servers, right? How the load balancer works. Now what we'll do, let me add okay, another server, and we'll see if there is some, right, something increases, like the request increases, like the user customer increases, when we need one more resources to be added. So what we'll do, we need to add more server. As we have not set up the auto scaling, we cannot create another server automatically. So we have to do manually create a server now. So let me quickly go ahead and set up one more server from the launching template. Okay, and let me see. So I'll just add it to a, go to the advanced section here. Okay, and just just paste it. Sorry. Okay, so I have not copied it. Okay, so let me add it as server 3. Let me add to the server 3. Server 3 here. Let me add again some spaces here, right? I should have copied this. Fine. Okay, cool. So it's being added server 3. Let's launch the application. View the launch template. So just wait for a few seconds. Our template, our new instance will get ready. So it is in pending status now. Okay, so the server has started running now. So what we can do, we can, so once we get new servers, we can get suppose 5 new servers. Okay, so what you will do, immediately you have to update the target group. You don't have to update anything into the load balancer. Only thing you have to update into the target group. That's all. Load balancer will automatically keep pick it from the target group template. Okay, you don't have to modify or add anything. Simply just click on this target group. Okay, and you can see here we have this register targets, right? That means we have to we are going to register new targets here. Just click this register targets, and we'll see here the number of available instances. Now we'll see 3. See, now we have 3 available servers. We already have 2 registered. These 2 already registered and healthy are running, and it is associated with the load balancer. Okay, but this new server is not associated. Which one? This 80A, this server is not associated. So what we can do, select the server which you want to associate. Just click on include as pending below. Okay, now you can see here it is now has come here, but it is in pending status. So here it gives register the pending targets. Register it. So now my template or the target group is ready. So we have total 3, but only 2 healthy. So it is doing the health check immediately. So as soon as we add what we learned in our theoretical, as soon as we add new servers, the load balancer will start doing the health check. So now our load balancer has performing the health check in the target group, and it finds another server added here. So it finds and did the health check, and it finds it is working, and the healthy servers are 3. So if we go to our load balancer and DNS server and see server 1, 2, 3, all the requests equally distributing to the server 1, 2, 3. All 3 servers are working. Okay, now let me just stop one application. The servers will be, let's see what is happening. Okay, let me stop, not stop the server. I'm not stopping the server. Now I'm stopping the application. Okay, now I'm stopping the application. Let's see what is happening. Then I'll terminate a server and we'll see what is happening there. Okay, now if I go to the EC2 instance here, sorry, not this one, right? Go to the EC2 dashboard, and if we find the, I need the IP address to connect to the server. Okay, I'll stop the Apache server there, and we'll see the health check. We'll see how the health check responds, and then we'll terminate one instance and say how it is working also. Okay, let me get any one of the server and let me connect to that. Okay, let's go ahead. Okay, so let me just go to the, okay, so I can see systemctl status httpd. Okay, the server is running. Let me stop it. Sudo systemctl stop httpd. So it is inactive, it is now dead. Okay, it is stopped. So the server is stopped, it is dead now. So let me go ahead and check the, let's go to the group, target groups. Okay, and here we can check the server's health. Okay, we have still 3, 0 unhealthy. Okay, just wait for few seconds because the server is yet to sorry, the health check is yet to be performed, right? So just wait for a few seconds here. Okay, okay, what happens, it still finds the index.html. Okay, now you can see here one is unhealthy. You can see, right? Now it has checked the load balancer has performed the health check on every server, all the servers, and it found one of the application is down, and it immediately responds that it is one of the server is unhealthy, the health check failed, right? Unhealthy. Similarly, if one server is goes down also, like terminated also, will have still, if I do here, we have still our applications available, right? We have still our applications out of 3, 1 is down, we have still our applications available to serve the request, to handle the request from the customer. So here we are having the high availability of our application, so we set up the high availability applications. Now you understood clearly how you set off the load balancing and all. Okay, do you have any doubts so far, guys? We can discuss something if you want, or we can just move on and I'll show you some other details. So Sunil and
Can you simply
Sanjay,
try that use case which we discussed yesterday? We'll
yeah,
just terminate the instance and then see.
we'll terminate one instance, then
Uh, then the target, like when we create, like the use, okay. So the use case is something like this. We created one instance from an AMI
okay.
and we terminated it,
Mm-hmm.
and we just wanted to reach that instance from the same AMI,
Mm-hmm.
and how this load balancing will happen.
Yeah,
Do we need to manually change anything of it?
exactly. So here, okay, I got your point. What is that we had discussed yesterday? Yes. So here, that is what I told you. If we are going to add the auto scaling to the load balancing, then it will be automatically added. If you don't have auto scaling added to the load balancer, then manually you have to add new server. That is why I added a new server, the third server, manually, right? You cannot, it will not automatically capture until unless you add it in the target group. And the target group additions you can automate by yourself, or you can manually add it. So automating by yourself, you have to add either auto scaling group, or you can add any other scripts or Terraform or anything to automatically add into the target group. So the load balancer works based on the template available or based on the target groups availability. So whatever the servers is available in the target, that will be only handled by the load balancer. So if any one thing is terminated and if you want to add it to the target group, you have to manually add it, or you can write sorry, you can set up the auto scaling group to automatically add that one. Okay, or you can set off the script. Okay, for auto scaling group,
Okay.
we'll just see that one once we finish the auto scaling, because the auto scaling class also will take 1 day of class for auto scaling also. So once we finish the auto scaling, we'll see how we can add both auto scaling and load balancing. Okay, we'll see how we can add both auto scaling and load balancing. We cannot delete manually. That is what I showed you. We have to manually add into the target group. We have to manually
Okay. Yeah.
register the targets here, and the load balancer will automatically capture it. Okay.
So Ranjit, it is we are using load balancer as a default or as per client requirements. Like if it is their requirement, then we are using load balancer
Okay.
because it is distributing the traffic equally among the servers, right?
Exactly. Good. So Sunil, can you please just explain? You have some ideas on load balancing.
So, yeah, the Route 53 in this case is a service managed service provided by AWS. But let's suppose the client don't want to use Route 53 and you want to have your own hardware load balancer provided by some other vendor. For example, you can have Radware, that is a service provider which gives the solution for load balance. In that case, I think you need to have the hardware load balancer installed somewhere in the AWS, maybe in EC2 or maybe in EC2. And then an administrator can manage all the load balancer and traffic through Radware. I'm just giving an example right there because that's a hardware load balancer provided by some other client and not managed by AWS. So yeah, and the if your question is more on how the load balancing should happen, that is purely how you want to distribute your traffic. Maybe a round robin, preferable for um, normal loads, but let's suppose you have a high amount of load coming every second, you may need to think about deep connection or um, the instance which is performing or the response time from the instance which is high, the traffic will go to there. So there are different logic and different algorithm how you can set up your balancer. So yeah, did I answer your question?
Yes, yes. Thank you.
Okay. So
Yeah, to
Harsha,
add on top of
yeah.
just to add on top of that, right? I mean, generally, load balancers are part of the deployment architecture, right? In the sense, uh, it's a requirement for an high availability, right? Generally, I mean, that is what I have
Uh,
seen for all the applications, right? So,
exactly.
uh,
So it is
it's,
actually depends on the requirement. So Harsha, Abhishek, whoever was asking, so it is actually depends on the your requirement. See, if again, if you are you have to understand your application first. What is your application and to whom you are targeting? If your application is standalone, only single application, and you have very fewer resources and fewer resources and fewer customers, and you don't have to set up load balance unnecessarily, because you have to pay more if you are going to set up load balancer, because you have to buy one more server, you have to buy the load balancing, you have to use that, and you have to pay more. Okay. And that's what you have to decide, you have to see, and you have to understand your applications, how many, or what is your target, what is your customer, what are the customers you are targeting. Okay. And
so generally, when you set up your dev environment, you have a bunch of environments, right? Dev, QA, pre-prod, prod, and all, right? So
exactly,
dev and QA, generally, you will not have
load balancer,
multiple instances, right?
yes,
High availability is not required.
not
So in those
required,
cases, you might not set up a load balancer.
load
It's
balancer,
mostly on your pre-prod and prod, right? Where you, like pre-prod is basically a replica of in a lower scale, right?
yeah.
Of your production for do a load test and all those things. So there you will have a load balancer setup where there is multiple instances where you want to balance it across, right? Make it high available and all. Right?
Yeah, exactly. Exactly. So in production, most of the companies they use a load balancer in the production environment. as I said, as Sanjay to also said, like in development and staging, testing, we use minimal servers, one or two servers, so we don't need our next, like it is not like high availability is not required. If the dev service goes down, we still can wait for the development to continue, to resume, because load balancing setup actually cost effective, so you have to pay more for load balancing, right? So that's why not necessarily you have to set up every time the load balancing. Only production server where you're targeting multiple server and giving commitment to the customer high availability, then you have to go for load balancing. Okay, hope this is clear. And what you do, as soon as you complete this load balancing practice, I would say guys, you do practice today, okay, or else you'll forget it. Just do practice today, and once you do practice, just delete the load balancing, because load balancing is required more than two servers to create, and it will charge you. Okay, so today morning only I had paid around 345 rupees for using the EC2 instances for uh, computing platform. Okay, so it will give you charge. So how you'll do the billings and all, sorry, I had paid 103 rupees or something for this month. Okay, so let me just clean out this first. First you have to delete the load balancer. Okay, then only you can go to delete the target group. Okay, first you have to delete the load balancer, select it, delete, it will immediately delete, clean. Now go target groups. Okay, and then select the target groups, action, delete, delete. So the target group also will be deleted now. Okay, no target groups. Now the time to clear out the instances. What are the instances is being created, right? So all three instances unnecessary, I'll pay for this. Let me delete it. Go ahead and terminate. Okay, so by the time it is terminating, I'll show you the billing, how you check your billings every month. Okay, so you better you check your email address, whatever email address you have provided, but sometimes we provide the email address which we don't much visit that email. Sometimes what happens, AWS always send the invoice and notifications and reminder to your email address. If you don't monitoring your email address, after 3 or 4 consecutive reminder, they will suspend your account. Okay, so if I go to my billing structure, okay, just go to your billing service. They have a billing service available. Just search for billing. Okay, and you'll find the billing and you'll see the invoice details and everything, right? Go to the billing section here, billing service. You can see lots of things are there. Okay, so in your home it will show you the billing dashboard and how much you are going to pay for that, right? So total number of active services 5 add. Okay, so all the cost details it will give, just wait for a second. Okay, so the account is being charged for $1.30. Okay, $1.30, it will be approximately 103 rupees something today morning I paid. Okay, so if I go to the order and invoice, if you go to order invoice, it will give you, as I paid already today morning, there will be nothing available for payment. Okay, so I just made today, and this is the invoice details. Okay, I paid 102 rupees. So if I download this invoice, it will give you the details what you had used and why they have put the charges. Okay, if I go ahead and just open the invoice, so this will explain you. See, they have put the charges of $1.30, totally 10266 rupees. And for details they will give you. For S3, they have not charged anything. For data transfer they have not charged anything. For CloudWatch, for load balancing they have not charged anything. Here they have charged for Elastic Cloud Compute, that is for EC2. They have charged $13 rupees, charges 1.10 and 0.20 GST, total 1.30. Okay, so you have to frequently check after 1 month or 2 months, just check your billing. If you are not monitoring your email address, just check your billing and check your payment dues will be here, and you have to pay it. If you don't pay it, they'll suspend your account. Okay, that's all guys for today.